Now let's apply our knowledge of volume to find the volumes of more complicated shapes, such as the prisms here. So in this example, we've got a shape and we are given the dimensions. So we're given a height of 1.2 meters, we're given 0.9 meters along this length here, we're given a breadth of 0.5 meters, a height of 0.5 meters here, and a total length of 1.6 meters. So there's various ways that you can calculate this, but the way that I'll be showing you is by thinking of this as two separate shapes. So we've kind of got a smaller cuboid at the top here, and that's on top of a larger, more elongated cuboid at the bottom. So we can split them up like this. So let's take the smaller prism first of all. We have to know what the dimensions of this are to find the volume. So if we go back to our diagram, we can see here that we're given a length of this of 0.9 and we're given a width of 0.5. But what about the height? So if we go back to our diagram, we can see that the total height from here to here is 1.2 meters, and we can see that the height of the longer prism is 0.5 meters. So the height of this one is just the difference between the two. So we can subtract this one and that subtract those two, and then what we get is 0.7 meters. And now we've got length, breadth and height. We can multiply them using our formula for the volume of a cuboid, and what we get is 0.315 meters cubed. Now we can do the same for the larger prism. Looking at our diagram, we can see that we're given the dimensions. We're given 0.5 for the breadth, 0.5 for the height, 1.6 meters for the length. So we can actually just go ahead and multiply these using the formula, and this comes to 0.4 cubic meters. And so now we've got the volume of the smaller prism and the volume of the larger prism. We're going to add these together to get 0.715 cubic meters. Let's go for our capsule example, and we're given the dimensions of 10 centimeters from these 2 points, and the total length is 16 centimeters. Now this capsule consists of 3 shapes. We can see here that we are given this as a combination of a central cylinder shape, and we're adding 2 hemispheres at the end of this, so 2 half spheres. We can rearrange that and say that 2 half spheres make up a whole sphere. So what we've effectively got is a full sphere plus a cylinder. So what about dimensions? Well, what's the diameter of the sphere? Well, we've got a difference of 6 centimeters between the length of the cylinder and the length of the total compound shape. So we can say that the diameter of the sphere would be the difference, which would be 6 centimeters. So we can say that the diameter of this is 6 centimeters, which also equals the diameter of the cylinder, which would also be 6 centimeters. Okay, so let's go and calculate the volume of the 2 hemispheres, which we've modelled it as a full sphere. We can say that the volume is 4 over 3 pi r cubed. Well, in this case, r, the radius, is going to be half of 6, which would be 3 centimeters. So we can say that it's 4 over 3 pi times 3 cubed, which is 113.1 centimeters cubed, using your calculator and rounding it to 1 decimal place. How about the cylinder? Well, the volume formula for the cylinder is the area of the surface, which is pi r squared, as it's a circular surface area, times the height, or in this case the length, where height is 10 centimeters and the radius again is 3 centimeters. So we put this into our calculator and we get 282.7 cubic centimeters. And now we've got the volume of the 2 hemispheres and we've got the volume of the cylinder. Therefore, we can say that the total volume is the addition of these, which is 395.8 centimeters cubed.